Yeah.
Hello,
Hello.
I'm Augie.
And I'm Gavin. We're from the Grower School.
We like to build stuff, and we're gonna try out this
Format,
video format to try and keep ourselves
Accountable
and actually on time for this
Yeah.
project. Basically,
Our project.
we're gonna build a CNC machine. That is the plan.
Hopefully.
We want to build a CNC router. Originally, we thought about making a mill, but then we realized that it's probably a better idea to do a router, and it's gonna be more useful, more flexible for us.
Backstory, we're on the robotics team at our school, so we have a much larger need for a router opposed to a mill.
Custom side plates and that kind of stuff.
Yeah.
So, based on this, we've already done our background research, and then we thought this would be a cool idea. So, the outline for this project, we have a few constraints.
Yeah.
To start, obviously we have a budgetary constraint because, money.
Expensive. Money costs money.
We're doing this for our physics, my physics honors project. He's getting credit in physics for it. And basically we have about 100 days or like three months-ish to get this done. Neither of us have that much time, so we're going to be kind of doing this weekly and trying to get as much done as we can. So as we said,
I'm just gonna say, like, we're probably only gonna spend probably, like, I don't know, 3 to 4 hours a week on this.
Yeah, it's gonna be. We'll see how it goes.
We'll vary it with what we need.
But in terms, so just to lay it all out, in terms of cost, we're trying to go around $500 to $600 max, and then if it works, we might
upgrade some
parts a bit
to be able to.
But we have to kind of prove that we. A lot of this is coming from ourselves, and we're hoping to get some from our school to fund it. But this is a project we've been wanting to do for a long time. So
I mean, we've been working with like 3D printers and other whatnots for quite a while now.
I guess that's a good idea. So what we have is between the two of us, we have 3 3D printers, and our school has another 3 or 4.
Yeah.
Additionally, we have a laser cutter at our school at some point. It's not operational right now, but we will have it.
Will be done.
And we have the shed full of tools, and we're gonna go for it. At school, we have a bunch of aluminum extrusion already.
What grade are we in?
We're in 11th grade.
We're both juniors.
Yeah, we're both juniors. We've done quite a few projects before.
Yeah,
so
we've taken an engineer. I mean, both of us.
Yeah.
Taking an engineering design class. And me personally, I've taken a coding class, and you've been coding.
I've been coding for multiple years. Code shouldn't be too bad, but we'll see how this goes. Aside from that, we have a fair amount of like aluminum extrusion parts from our robotics team. We have a lot of wood, and we have filament. So we're gonna see what we can do. A lot of the cost is gonna go towards all of the mechanical parts in this.
Electrical.
And I guess to summarize the research we've been doing over this last week, Gavin, you want to talk about materials?
Yeah, okay, so the material that we're going to try to use, like, the most, really, is going to be aluminum and PLA, which is what comes out of, like, your 3D printers and what we'll be mainly printing in. For the aluminum, as we said earlier, we have tons of aluminum extrusion at the school and at our disposal. For the PLA, it's a plastic, so it's not doesn't have very much like substantial weight to it. But what we've decided and seen in many videos before is that people put concrete in the 3D prints to give them some more mass and a little more rigidity. And that's kind of for our like basic materials, really. I mean, we're gonna try to have a lot of it 3D printed and try to cut down on costs that way.
Yeah. So the goal is to design this whole thing in CAD before we start building, because that's going to make it way easier for us to figure out if it's hopefully going to work. So that means that we're going to have all the models. We're tracking them in a spreadsheet that we created. We haven't really done this kind of thing before, but we're tracking its location, its status. It's like we're trying to keep very, very much track of it, and I might show a picture of that right now. But that's the goal. We want to use that. And aside from that, 3D printed kind of shells with aluminum extrusion for reinforcement, and then concrete just to give it actual structure is kind of our idea.
I mean, we're going to be a Core XY, right?
Yeah, it's a Core XY. We want to do dual Y-axis drive, and then possibly sacrifice a bit of the strength of the x-axis and have a smaller stepper motor just to save costs. Because we did take apart a printer at school, and we have a few random stepper motors, but we haven't used them, so we're going to see how that works out. Yeah, in addition to that's our basic structural materials. We did some research. We talked about our stepper motors. We're hoping to get those in a kit with drivers and a power supply.
Yeah, I mean, I think something that's like really important that we're going to be purchasing that is very like it has to be there is the rails, which are going to guide the sled that we're going to have our Core XY mounted to. And we've kind of been looking through a couple different types of slides. We saw one video. This person used a kind of like a semicircle slide. So I mean, we'll show a photo of that probably. Yeah. We took a look at that, and we also saw another one which was a full circular slide. So it was a full metal rod instead of just like a half metal rod. That was also another option, and the last option was kind of like a more traditional rail type system, which is like a flat rail, kind of rectangular. I mean,
yeah, just flat rail with kind of a carriage on top.
Yeah, I mean, we were talking about kind of what we want out of these rails. Like we want them to be very sturdy. We also want them to have very low tolerance, so we can have an end result that's much better. I mean, looking at the circular type rails, we kind of discussed that we don't really gain very much from it being circular. You know what I mean? Like and it also opens up the opportunity for twisting, unlike the flat rails that we saw.
Yeah. So we're planning on working with flat rails. If we don't encounter any errors, that's what we're gonna go with. And yeah, in terms of, we already spoke about the stepper motors we're getting. When we solidify this, we'll provide like a bill of materials of what we actually used. But the plan is to do a lead screw based system where the stepper motors are just driving lead screws like your standard 3D printer. Because we have seen that, we know it works, and we have examples of that are very common online and both in our 3D printers. So we're planning on doing that. Our overall goal for this whole thing, which I suppose we should have said a little earlier, is we want to be able to cut metal with it. So
well, not quite metal.
Well, aluminum specifically. We wouldn't, like, steel is a bit of an overkill, but
yeah, I mean, we're definitely going to test on wood first, just to have that going.
Yeah, in order to do that, we're looking at a spindle that has that capability.
A spindle or a router?
Or a router, yeah.
Because it really, you're buying power and you're buying speed when you change from a spindle to a Makita type of router.
Router, yeah. So that we're still deciding, and that's probably going to continue being decided this next week as we continue to work on it. In terms of electronics, which is kind of the next step, we're planning to use a Arduino Uno. All right, the dogs were barking. So, where were we? Electronics is the next thing. So, in terms of electronics, which is kind of the next step after mechanical for this, we're planning to design all the mechanical and then
I mean, they aren't
fully
that
figure
bad,
out.
right? No.
Yeah, they're not that bad. As we said before, we're getting motor drivers with the stepper motors, so that should work out pretty well for us. These motor drivers are designed to run with Arduino, which is lovely because I have experience programming Arduino, and so does he to a point.
Yeah.
I do the programming. Basically, we're going to be using pretty much the same kind of infrastructure that you have for a 3D printer, so that's limit switches and stepper motors. So we're buying a pack of limit switches off Amazon, and then the stepper motors wired to the motor drivers, wired into an Arduino Uno or Mega. Pretty sure an Uno will work. The Arduino Uno is going to be running a Gerbil version. I'm not really 100% sure how that's going to work, but there is software that runs for CNC machines on Arduino that we're going to use. Alternatively, we thought about using a Raspberry Pi, but seeing as it's expensive, it's like $60 plus CNC hat, and also the motor drivers seem to work well with Arduino, and we've seen an example of them working with Arduino, so we're going to follow that a little closely. And aside from that, that's pretty much what we figured out so far. It's a rough idea.
I mean, I guess like some less important electronics that we'd be we would be kind of implementing are going to be like a vacuum system on the
Hopefully.
a vacuum system to clean up the chips and create like a little
Maybe
more
some
accuracy.
form of like water pump to keep the spindle.
Yeah. If we were to upgrade from using like a Makita, like we said, to a spindle, most spindles are water cooled, so we'll have to have a little more complicated setups.
But that's going to be in the future if we get it working roughly. And if it works well enough for us to really want to upgrade it. I mean, we want to build it, but if it works, just not amazingly, we're probably going to keep upgrading it anyway. But that kind of upgrade will be in the future. I guess the other stuff, we're planning to use M4 measurements just because we have a lot of those screws at school. We want to standardize as much as we can and just adapt all parts that aren't that measurement into that measurement.
I mean, we're going to have parts that aren't going to have M4, but that is just, it happens.
So we're going to head over to the whiteboard that we have.
Yeah,
and do a little bit of a preliminary design. So, what we now have, just to give you a little bit, there we go. Yeah. What we now have is a very detailed, very perfect diagram of what we kind of want to do.
Yeah.
And we didn't really do anything beforehand, so, sorry, our robotics team is
rapidly approaching.
Yeah. You talk quickly.
Okay. So, for our X directional movement, we're going to have an overpass bar. That's going to be here. The red is generally going to be stepper motors just for our drawing. Ignore these, please. These are just feet. I'm being bad at drawing for a second. So we're going to have a stepper motor on the far side of it so we can drive our screw, which is right here across the top. And that is going to move our Z piece, which leads us to our Z piece over here.
Very detailed.
Yeah. So we're going to have 2 inline rails here. And these rails are going to be the flat plates we talked about earlier, the flat rails.
So they're going to be like pretty much a rail.
Yeah, they're just a rectangle with another rectangle.
A carriage on it like that.
Yeah.
And bearings within that carriage.
And then that's where we're going to mount our, we're going to be mounting the router or spindle, whatever.
There.
And then, Anyway, stepper motor, like I said.
Stepper motor we're going to mount on top of the whole
and it's going to be done with a screw.
With a lead screw.
Yeah, lead screw.
Then, in terms of why we're doing... This is kind of where a lot of our thought went into, and I didn't understand the plan initially, so it was explained to me, which you probably saw. But basically, we're doing a dual Y. And this is going to be connected to this whole gantry system, which here you can see we drew circles for rails. It's going to be flat rails, but it's just easier for us. And basically it's going to be moving along the outside is going to be the rails. And then these inner bits, this is where the stepper motor screws are going to be. And we're going to have a whole assembly that goes under the build plate. The build plate's going to be, as we said, attached on the 4 corners. But under the bit that we're cutting, we're going to have this little bit that's connected through to our whole gantry that moves with it, which will add stability to exactly where we're cutting.
We'll probably throw in some 3D models.
Yeah.
Now.
Maybe. We'll see if we get them done. But yeah, that's everything we've talked about, aside from that bit, which is going to be the base, is going to be moving on this gantry, which is why we're going to be using a dual Y system. The stepper motors are going to be mounted under the assembly, which is going to be secured at both ends with a big flat sheet. That's probably going to be plastic filled with concrete and some aluminum extrusion, whatever we can do to make that solid.
Yeah, I mean, filling with concrete, like we said earlier, just adds so much rigidity.
We're probably going to add, rigidity, strength.
And then, just kind of mellows out the vibrations and...
Hopefully should work.
Yeah, I mean, it'll all be raised up on some extrusion probably as legs with some like TPU feet, you know, for little grippy feet.
We're going to add some wire channels through the concrete extrusion bit so we can get wires to these stepper motors right here. Yeah. I want to have all the electronics away from that in case... I mean, it'll just be better. It's a better policy. It would be cool to have them under here, but I'm a little worried about that, and frankly, it doesn't hurt to have them in an exterior module, so we're going to have...
one of the nice things is that like we don't really have a size constraint.
Yeah, we can figure it out.
Yeah.
But this exterior module is either going to be connected somewhere on the machine very lightly or going to be independent and just wires. It's going to have our power switch, Raspberry Pi, motor drivers, all that in there. This isn't really designed yet, but
kind of just throwing around ideas. And for our build plate, we do want it to be 500 by 500. I don't know if you mentioned that yet.
That is the goal. I think we mentioned it, but our goal is a 500 by 500 build plate. As we said, we're part of robotics, and we compete in FTC, and the maximum size for robots is 18 inches, which is around 457 millimeters. So if it's 500, that's great for us. We can print anything we need for our robots, or cut anything we need.
Yeah, for us printing metal.
Yeah, printing metal. What is it? SLS? The
SLM?
Is it SLM?
Pretty sure.
Yeah. Yeah, you had an idea for like the peg on the build plate. If you want to talk about that to keep all the...
Okay, so this is kind of like I don't know exactly how we would do it, but I would suggest we use like a standardized sheet that we'd be using. So what we would do is we would have our build plate about yay big, and then I was thinking we would like just create a bunch of holes that are like a grid of holes, right? That just kind of go here across this direction and also this direction, right?
Yeah.
And doing this will allow us to have many mounting holes. And we could put just little like corner stops, and we could mount practically any size of sheet aluminum that we would be putting in here.
Yeah. Keep it stable and secure.
Yeah, and it just gives us a lot of mounting holes, really, which is the thing. A lot of options, really.
Yeah.
But beyond that, it shouldn't be too intricate in design and make. This could be theoretically manufactured out of... we could be 3D printing this and then putting heat insets, and then if we are able to get an okay print with that, not print, cut. That's what I really mean to say. Yeah, we're really used to talking about 3D printers.
Yeah, because we have not had any
formal
like
thought about this. But yeah, we could theoretically cut some aluminum, a new aluminum build plate, which would be cool.
The hope is if it works, then we use it to make it better by cutting aluminum pieces that we then replace the plastic pieces with and just do that. Yeah. Which would be amazing.
Upgrades.
If we could do that. We'll see how we do.
Yeah.
But yeah, that should cover it. We'll post images within the video of whatever we talked about. And there will be credit for any people's videos we have looked at down in the comments or the description. We're hoping to do this like on a hopefully weekly basis as we work on it. We want to, as we said, keep ourselves accountable, document it so we can use it in the future for like portfolios if we want it. Thank you for, if anyone watched this, thank you for watching.
Bear with our...
We ramble a little, so thanks for patience.
Try to keep it
concise.
Sure.
Yeah.
That's a word for it.
All right.